Now let's talk about something that every AI developer or software composer eventually learns into. That is context rows. So how does context rows occur? You are in a chat with an AI building a system whereby you're instructing the AI what you want it to do, and then in return it's providing code. Now normally what happens is at first it's fast and very responsive and also very sharp with the way it replies. You might get at the first stage what you want, but as the code piles up and the project gets heavy, you all of a sudden start to experience the model may start having hallucinations, it may start imagining things that are not there, or it may even get out of context. Okay, yeah, so that's where you eventually end up with context rows. Now here's the truth. If you are building a full system through chat, maybe like we do using software composing, or developers who rely on AI to code, you will eventually you'll never actually fit an entire app into one composition. It is technically impossible to do that. So the way out of this is to actually design around it than fighting it. Okay, so what you should do is now what we are calling today context modularity. Okay, now what is context modularity? So context modularity means you structure your AI development process the same way you would structure your software architecture, or what we call the code base. Okay, so in simple terms, if your software is modular, your context should be modular too. So you can think of it as a chart container of understanding. It can hold the logic, design, and files for only one clear scope. So you match the scope with the software module, one chart per module. So this will help you focus and maintain the context by reducing the required amount of context, so it will only be specific for this type of a module. Okay, so that's how you'll be able to keep your AI sharp, consistent, and efficient, because you have broken down the modules into smaller ones. Okay, now why does this matter? An LLM can only remember a limited number of tokens. So mostly, maybe most LLMs are normally capped at 200,000. That forms what we call the context window. Okay, so the context window limitations actually limits the memory that the AI can be able to recall whatever you are working with. Okay, so once it overloads, the model starts to forget, okay, the details, maybe all the context that you have given it, and it starts to get patterns, or it even contradicts itself. So instead of dumping your entire system into one chart, you can redistribute it. Okay, so you mirror your architecture across multiple sessions. Each chart becomes a workspace for a specific feature, like a payment module, a login system, or a notification module. Okay, now, and because each chart has its own isolated chart context, you can move faster, keep accuracy high, reopen modules later for updates, or even switch between AIs. Now, how do you do it? And this brings in the context modular workflow. Now let's break it down step by step. So this is the process we use to decompose our software. Okay, basically we decompose the system first. So here are the steps. So we decompose, we define, isolate, then integrate, and finally maintain. Now on the step 1, decompose the system, you start by breaking the entire project into small, clear components, the same way you design a modular code base. This is how you do it. So you list out the pages or forms in the system, the backend modules or services, their relationships and dependencies. Remember, you're not coding yet, you're just mapping the system's brain and how everything will be connected to each other. You're just having this visual or conceptualizing how the system will be working. So example, if you are building a college management system, you might have modules like a student module, a course module, an inquiry module, a payment module, a notification module. Each of these will become its own context space. So meaning you have separated it from, or you have broken it down from being one this major big modular into smaller modules, which will translate to smaller contexts, making the work easier for you when you're working with these LLMs. Instead of chunking in a whole system into one chart, causing confusion to you and to the LLM, and you end up not working on the project as you would want. Now the step 2 is to define the context capsules. So for each module, define what its context capsule include. Now the capsule will include the information about the file. So this could be something like the relevant tables or the schemas. Okay, the main files are associated to the module, the PHP files if you are calling PHP, and JS, etc. Depending on the language that you're using. The API routes it connects to how they communicate with each other basically, and short summaries of dependencies. So that's what you're defining to the capsule for a specific module. So this capsule is what you feed to the AI whenever you work on the module. It's like a self-contained memory unit for a specific module. So this is what brings in the actually the compatibility and scalability aspect, because previously people who do web coding or use AI to code normally face this challenge of scaling the application when things start to get more complex. With these modules broken down and well defined, having a capsule that explains well the files that they are related to, the modules that they work together with, they will make the work easier for you. Even when you want to add maybe more features or you want to add something, this will work. This will act as a point of reference, like a documentation of the module, explaining in detail what that module does exactly. Now in step 3, this is where we have to work with isolated charts. Okay, so the isolation development is basically working with isolated charts. This is what will actually make it possible to work with different AIs, but still work on the same project. Now you can start. Now when you open a new chart with the AI, you only work on one module per chart. So you start the chart with the context capsule, just enough information for that module to make sense. So for example, if you are building the inquiries module, you'll provide the schema for the module for the inquiries. That is maybe the information, the fields that you have in that inquiries module. The fields that you have, maybe you have the inquiry ID, name, you may have the contact details, okay, and maybe other information that you may want to record there. So this is what you'll be talking of, basically everything that is recorded in that table, everything that you want to capture in the inquiry module when you create maybe that module for managing inquiries, saving those inquiries, everything related to the inquiries. Then you show how it will link to other files, maybe the students and the courses, okay, and then instruct the AI to build or refactor only that part. So remember, you leave out other parts like the notifications. They will not be here, but if they are related, you can also add them. Maybe if you need to send a notification when a student or when an inquiry is made, okay, or anything that is related to this module. Then instruct the AI to build or refactor only that part. So by doing this, you prevent unnecessary context overload, and the model stays extremely focused on the subject matter that you'll be focusing on. Then the next step, which is step 4, will be the integration. Now once you have all these modules which you have built independently in isolation, you will have to actually combine them to work as an individual to achieve a common goal. Now once you have them, you have several modules which are built, and you can open now a new chart for integration. So now here you feed the AI high-level summaries of the code, completed modules, not full code, and focus on how they interact. Okay, so the APIs, the data flows, the shared tables, and notification handling. This keeps integration manageable and context right. Okay, yeah, so the context will be simple. It will be easily be, it will lose context since you don't read a lot of information. This will make the context be light and allow you to make adjustments easily. Okay, then come to step 5. Okay, so the maintenance and reuse. So when you later need to edit a module, okay, you don't need to reopen the routed chart. You just load the same capsule in a new session and continue. So remember, you are updating. So the capsule looks like something that what you are seeing here. So like we have, like, so example, we have a payment capsule, have a version history, what you added. Okay, it's like a gate of commits that which you did, but this one can be in more detail, meant to make an AI understand what you have been doing. So this is what will actually allow you to scale and move and jump into different AIs. Maybe if you have reached a chart limit, or you feel like the AI is now starting to hallucinate, you can be able to move with the working part of that module and exit into a new AI, and you can see that maybe if you are getting an error which a certain AI is not able to fix, you may realize that when you move it to a new AI, it will automatically maybe find it easy to fix it, and it will also gather and get all the information it needs to actually be able to make those changes. This is what will also contribute to scalability. Maybe then if the module worked just fine, you don't need to open the modules again and maybe say, oh, I needed to add this feature to this module. You can just put it into just any AI that you have access to and actually start it to make the amendment, because now it has all the required context and the files that she needs to actually be able to perform that action. It will do this easily without you having to worry, okay, about opening the project chat that you are working on maybe already now. Let's look at some of the benefits, and I've already mentioned some. So benefits will include the scalability, where you can be able to build interface system piece by piece. And the other part is portability, which is the main advantage is to move between AI models easily. We also have stability, okay, where you don't have the chart doesn't get so long, or you don't overload it, so there is no dragging or forgotten logic. Okay, then the other part, and then also very important, is collaboration. So now multiple people can be able to work on the same modules, or in different modules at once. Okay, someone can handle this module using a different AI, and another person can handle this module using another AI, and then at last you can integrate those modules to form a system that will have a variety of features and functionality. Okay, now the last part will be also compositional, which fits the software composing idea. Okay, because at the end you are composing those different modules into one to work together, just like music is composed, different elements are played, but they are all playing, they are all played in the same music or the same song. Okay, and now the philosophy of the music composing is that you are the director directing the AI. Okay, then you have the modules which perform various functionality. So your work is just to pick on which module to do this, and every module just plays its role. Okay, yeah. So apps are like music, conductor, but your code is the orchestra. Okay, now what's my final thought on this? So software composing is just about talking to AI. It's about directing it. And just like a music conductor keeps every instrument in sync, you, the composer, okay, keep every module in tune by giving it its own scope, its own space, and its own context. That's how we scale AI-driven development, not by pushing the limits of a single chart, but by designing context-aware systems that grow in harmony. That's context modularity, the bridge between modular code and modular intelligence. find this video educative or you find it encouraging, do consider subscribing. As in future, I'm looking forward to building more practical videos. I'll be showing you how to do this step by step, well documented and